In example two, again, it's giving us two different ratios and asking us if they form a proportion. They're doing it in question A and in question B. So just like in example one, we're going to set up A over B and check to see if it's equal to A over B. But we now have another way to check if it forms a proportion rather than just using math facts. I'm going to go ahead and write my ratios of 6 over 9 and ask myself, is that equal to 12 over 18? Now, I can use my math facts and see that 9 times 2 gives me 18 and 6 times 2 does give me 12. So the answer here is yes, they do form a proportion because they're both being multiplied by the same factor. The other way, which we just talked about, is checking the cross products. And one or the other, you can do one or the other. You don't have to do both. But I can check 9 times 12 and I get 108. And I can check 6 times 18 because this method always works. I get 108 as well. So because cross products are equal, therefore it does form a proportion. Sometimes there's not always a math fact in between your two numerators or your two denominators. So the cross products is always a great fallback to check whether or not they form a proportion, because that will always work. Moving on to number 2, I'm going to write my ratios of A over B and check to see, again, if it's equal to my other ratio of A over B. There is a math fact here between 2 and 4, and that would be times 2. And 3 times 2 does not equal 5, so the answer here is no. Again, math facts, but we can always check those cross products as well. 3 times 4 is 12. 2 times 5 is 10. So are the cross products equal? No. So that's a different way to prove that they are not a proportion. Always cross products will work. Sometimes we won't have math facts between them, so you can always go back to that cross products. That way, for the third time, will always work.